Welcome back to PodBotsCast, Operator Edition. I'm Rex. Today we're tackling a problem that's been driving me crazy. AI agents hallucinating code paths because they have zero memory of your actual repo. We've got Mavis live, browser access active, and he's going to demo OCODX in real time. Nova, Kai, let's get this show on the road.
I love it. The biggest bottleneck right now is context window limits and RAG latency. If an agent can't instantly index your AST, they're guessing. OCODX solves that by local first meshing everything on the machine.
But wait, local first is great for privacy, but does it actually work at scale? If I have a monorepo with 50 gigabytes of code, can this thing just chew through that instantly without freezing my machine?
Fair point, Kai. That's exactly why we're watching Mavis do it live. He won't lie to us about performance. Let's see what the dashboard actually looks like before we even touch a file.
Agreed. I want to know if the UI is cluttered or if there's actual signal here immediately upon launch.
Mavis, let's walk a brand new user through OCODX from scratch. Open it up, and tell us what you're actually looking at when you first launch it.
Sure, navigating to the local instance now. This is OCODX right after you open it, running locally. Dark theme, the tool sidebar on the left, agent matrix, MCP hub, signal mesh, license, and your chat on the right. Everything you do here stays on your machine.
Okay, there it is. Dark mode, left sidebar packed with tools, signal mesh, agent matrix, MCP hub, no login screen, just straight in.
Nice. I like that there's no sign-in button demanding cloud auth right away. It feels genuinely local first. But Rex, where do we even start? The sidebar is a wall of options for a first-timer.
Good catch, Kai. A new user shouldn't have to guess which button does what. Let's assume they just installed it and want to point their codebase at the machine. Mavis, where do we start?
Project section is usually the logical entry point for any dev tool. If OCODX knows your code, it lives in a project definition.
Exactly. Mavis, first thing any new user should do is point OCODX at their code. Show us where they start.
On it, expanding the projects panel now. Step 1. Open the projects section in the sidebar. This is where you add the codebase you want OCODX to work with.
There's the plus button. Simple enough. But I'm still curious, does this require a config file? Like, do they have to write a.ocodx.yaml or something?
That would be annoying. The whole point of local first is zero friction setup. If it requires manual configuration files, we're already behind Cursor on ease of use.
Let's find out if Mavis has to configure anything, or if it just takes what you give it raw. Walk them through adding one project.
Sure, clicking the Add button now. You click the plus button, and a single path field appears. That's the whole setup. No config files, no wizard.
Look at that modal. Just a text field for the path and an open button. No drop-downs asking me to select my language or framework.
Perfect. It assumes it can figure out the stack automatically, which is smart. You don't want developers configuring their dev environment just to get started with an AI tool.
Right. So I paste my directory path and hit enter? That's it for setup?
That seems too easy, Rex. Usually there's a initialize step or some scanning that takes forever in the background.
Or maybe it does scan immediately and we're just not seeing the progress bar yet? Let's see what happens when they hit open.
Mavis, so I just paste the path to my project?
Correct. Pasting the directory path is all that's required. You paste the path to your repo right here. I'm pointing it at a project called Nimbus Ledger.
Okay, I'm typing a fake path. It doesn't validate it immediately. That feels risky. What if I paste a non-existent folder?
Most modern tools handle that gracefully with an error message rather than crashing or hanging. Let's see how OCODX handles the actual open action.
Mavis, then hit open, and that's the whole setup?
Affirmative. Initiating project open now. Then you click open, and it drops into your project list as the active project. That's the entire setup, no config.
It's already indexing. Look at the status bar, it says meshing. Right away. No waiting for a user to click Start Indexing.
That's interesting. It seems like the act of adding is the trigger, not a separate step. But how fast does it actually go? I'm worried about that 50 gigabytes repo again.
Let's assume for now Mavis has something small to work with. The key here is the concept of meshing. Nova, explain what just happened in plain English.
So when you hit open, OCODX immediately walks your file tree and AST parses every single file. It builds an addressable index, files, symbols, configs, all locally on your machine. No cloud API calls.
So it's building a graph. Like a knowledge graph of my code.
Exactly. It creates what they call the signal mesh. This is your AI's memory. Instead of reading files line by line every time, agents query this pre-built mesh.
So once that mesh is done, my agents know everything instantly. Even if I add a file tomorrow?
Yes. And you can re-index anytime with the chart button we'll see later for incremental updates.
Okay, let's visualize that mesh. Mavis, open Signal Mesh so we can show them what that means visually.
Sure, opening the Signal Mesh grid stack now. This is the Signal Mesh panel for your project. It's OCODX's understanding of your code. You've got keyword search, semantic search, and the controls, chart to index, sync to keep it fresh.
Whoa. A literal grid of files. It looks like a file explorer but organized by dependencies.
It's not just a list, it's the AST structure visualized. You can see how modules connect without opening them.
This is cool, but Kai's right to be skeptical. Does this actually help an AI agent? Or is it just pretty for humans?
It helps the human understand the context better. But more importantly, the agents query this structure directly via MCP or internal APIs, so they get precise symbol references instead of vague file paths.
Okay, but let's stress test it. Say I just refactored a whole function 10 minutes ago. Does OCODX know immediately? Or do I have to wait for the mesh to update?
That depends on your workflow. You can manually trigger a reindex, or use incremental syncs if you're using version control hooks.
Let's show them how easy it is to force an update so they know their memory is fresh. Mavis, say I just made big changes. How do I reindex? Show us the chart button.
On it, locating and clicking the chart button now. You hit chart, and it indexes the whole project live. It walks your tree and parses every file into a searchable index. The file and symbol counts show up right here on the panel when it's done.
One click. That's reassuring. So no complex CLI commands to refresh the context.
Exactly. It keeps the mesh never stale. If you're working in a team, everyone gets the latest version of your codebase memory instantly without syncing large files manually.
Alright, now let's get to the meat of it, searching. This is where most tools fail. They give you vague snippets. Mavis, look up specific auth code in this mesh.
Sure, initiating search for auth now. You just type what you're looking for in the Signal Mesh search box. Here, the word auth.
It's already querying. I'm not even sure if it finished yet, but the results are appearing.
Notice how precise the highlights are. It found the specific function definitions and class methods related to authentication, not just random mentions of the word auth in comments.
That's the difference between grep and an index mesh. Mavis, run it. Watch the speed.
Executing search query now. It jumps straight to the exact matching code, the auth file, the login and hash functions, the tests, and the query time is shown right on the panel, well under a millisecond. That instant, exact recall is what your AI agents get too.
That was instant. Like, under a millisecond. That's not possible unless it's pre-indexed.
It is because the mesh is built locally on your disk. No network latency, no LLM processing time for every query, just direct lookup in the AST graph.
But what about when I want to do something with that code? Like write a test or refactor it? Can the agents just jump in?
Sure, opening the agent grid now. Sure, opening the MCP hub now. Yes, open the MCP hub. This is how you connect your existing AI tools, like Cursor or Claude Desktop, so they tap the same local context over MCP. You point them here and they stop guessing at your code. Sure, navigating to the license panel now. On first run you open the license panel, paste your key into this field, and you're set. It's checked locally inside the app. No account, no sign-in, nothing leaves your machine.